today's video we finish off making the tailstock die holder. We fit the handles and I'll show you how to drill the 3 holes in the correct position using a spirit level. But before that we have a Banggood tool review, some 321 blocks and some ER30 collet holder blocks for the mill. So let's go into the workshop and see how we do it. I have some more products from Banggood. These used to be called 321 blocks, but now they're metric and they're 75mm by 50mm by 25mm. They're hardened steel blocks and they're hardened between 57 and 62 HRC. 5 of the holes that go through the parts are tapped 10mm and the other holes are just clear. When you get them, they come like this. They're wrapped in tissue paper and it looks like it's impregnated with some sort of grease. So you need to get the tissue paper off and remove the grease with some solvent. Then what I'll do when they're not in use, I'll give them a light coat of WD-40 just to prevent them from rusting. There are 2 in a set. They're useful to bolt to the milling machine, using them as fixtures or stops for a certain height. You can clamp through the holes and bolt them together and make up the length that you need. The sides are precision ground. I'll put a link to these at the beginning of the video in the description box. Once you've taken the tissue paper off, they look like this. They're still covered in grease, and the easiest way I've found of cleaning them is get a plastic container, put the part in, get some car, brake and clutch cleaner, and I'll just spray them with the cleaner, wait for a few minutes until the grease dissolves, and then using a clean cloth, wipe them over and remove the grease from the surface. That should remove about 90% of the grease, but you may still have some in the holes and threads on the parts. The blocks are ground to within 0.005 of a millimetre. 5 of the holes are tapped 10mm, so you can bolt them together to form different lengths and shapes. If you bolt them end to end, you go up to a length of 150mm long, or you can use them as parallel bars to locate components, or use them as a tool reference block where you can bring your tool up to the part and use it for setting. I also have some milling blocks. This one's a square block with an ER32 collet holder, and this one's a hexagon block with an ER32 collet holder. You've seen them on YouTube before. I'll just take them out of the box and remove the plastic bags and see what they look like without the packaging. On the front of the video, in the description, I'll put a link to the website. They have a light layer of grease on. What are they? So first of all, let's look at the square one. It's a ground square block with an ER32 collet holder in the end, and you get the nut. You do not get the collets with this. You can buy these in other collet sizes. So if you look on the internet, you'll find them in different size collets. I had these ER32 ones because I've already got a set of ER32 collets and they're useful on the milling machine. But this one's just a square block, so whatever you put in the collet, you can turn it in the milling machine vise and get 4. So if you want to produce a square on the end of a round bar like a chuck key, you could do that easily on that. This is a similar idea, but it's a hexagon, and what you could do with that, you could put a hexagon on the end of a round bar if you wanted to use it for a spanner or something like that to hold. If you wanted to form a hexagon for a bolt, you could do that quite easily with these. So let me wipe them over and get a collet. This is the standard ER32 collet. Here's the nuts. That fits okay. What I'll do is I'll put a 1/2 inch dowel in there. Lock it up. Hey, this is the hexagon block. I've got the comparator stand. I'll slide the block under and we'll set that to 0. Now, because it's a hexagon, obviously there are 3 different sides, so that's 0. Let's look at the other side. 2/10 plus. About 3.5 plus. 0. So you've got 3.5 of a thou variation in that. I'll check the square block. I'll set that to 0 there. So there's 4/10 difference between the 2 sizes. So there we are, a couple of milling blocks, one for milling square, one for milling hexagon. Both the R32 nuts and collets, but as I said, you don't get a collet with them, you just get the block and the nut. No doubt we'll see these in use on the milling machine in future videos, and I'll put a link at the beginning of the video to the 321 blocks and to these 2 milling collet blocks. I've fitted my tool post spindle in the tool post, and I've zeroed the tip so it's on centre line by adjusting it up and down with the tool adjuster and using my tool setting dial indicator. So now I can come into the chuck and using just a standard square on the side of the chuck. These 2 faces are parallel with the bearings. Loosen the tool post and just align it so these 2 faces are square. Lock the tool post. Now I know that's square with the part. So the next thing I need to do is set my drill position in from the face and set the rotation of the chuck to the right position. I've put a 2mm diameter rod in the chuck. Using the feeler gauge, I can just feel the pressure on that between the face and the rod. So that's just holding there nicely. So now I know the location of that 2mm rod, so I can pull this out, moving 1mm. So now I know that the centre of my chuck is on the face of the component. So I'll just change the 2mm bar for a centre drill. If you look at the centre drill, you can see that it's on the centre of the drill itself. So I need to move in 0.125 imperial, which is 3.175 in metric. There's 3.175. So now these 2 jaws are set level, which means they're at 45 degrees to the centre line. All I have to do now is centre drill this. On the end of the tool post drill. I'm just using a battery powered drill. I don't know how much power's in the battery. Let's have a look. Just put a centre drill mark there, and then I'll change to a 3mm drill. Now we rotate the chuck 45 degrees. I can still use my spirit level across the two chuck jaws, but this time I need to adjust the angle to 45 on the spirit level. Just about there. Just turn the chuck round. Turn the chuck until the spirit level is in the correct position, and then with the centre drill go in and mark the other hole. Change for the drill. And I'm just putting the centre drill back in to chamfer on the edge of the hole, which will help guide the tap. Now I rotate the chuck the other side like that. Spirit level across the two jaws again. Just tap it until the bubble is in the centre. Move the centre drill back in. Mark the centre hole. Place the drill. And that should give me the 3 holes that line up with the die. Yep. So the next thing to do is tap the 3 holes. I'll just explain how I set this chuck. On the die holder, the 2 outside holes, this one and this one, are at 90 degrees to each other, and the middle hole is 45 degrees. So I thought, how could I do this in a lathe? I noticed that on the outside edge of the jaws was a 45 degree angle. So if these two are level, by using a spirit level, I could turn the chuck in the lathe get the spirit level reading level, and I would know that these two jaws are at 90 degrees. So what would happen is, because I'm drilling from my tool post coming in this position, so when I get the top of these two level and drill in the side, be 90 degrees to that. Then to get the offset each side, the 45 degree one, all I did was alter my spirit level to 45 degrees on the back here, set that to 45, and turn the chuck. I put the chuck in back gear so it's harder to turn, and then when the two jaws are in the correct position, the spirit level will show the level, and the component then is in the correct position to drill the second hole, and then all I do is go back the other way and get these two jaws at 45, and then come in with the drill to drill the third hole. So the next job is to get the three cap heads I have, which are 4mm cap heads, and all I need to do is put a point on the cap heads so that it goes into the dimple. I prefer cap heads because they have a bigger Allen key, so if that was a grub screw, the Allen key would be very small and you tend to round them off. With a cap head, it's got a bigger Allen key than a grub screw would have. I've just put the die holder in the milling machine vise, and I've just marked roughly the centre line. Obviously now I need to get the centre of the two jaws so I can drill a hole and tap on centre, and this is the way I use the digital readout to do this. I'll lower down the head, and this is just a ground bar, doesn't matter what the size is. Move the y-axis over, and using a feeler gauge to get in between the vice jaw and the ground bar until I can get a feel that the bar there is just pinching that bar, and just holding that feeler gauge. So I'll set my y-axis to 0, move the other side, feeler gauging again, just pinching it there, and that's giving me a reading at 25.4. So now what I do is press my y-axis, not the 0, the input value, press Y, and then press half, and it comes up with 12.7. So now I can move this back until the y-axis reads 0, and that should have positioned the bar in the centre of the bore. The position of the y-axis. Now I'm going to do the x-axis, and all I'm doing is bringing the same bar until it touches the face, which is there. Now 0 the x. I can lift this up, and what I need to do is move in so that the centre will be ½ inch in from the end. Now I know that the dowel in there is 4mm, so I need to bring the x-axis forward 2mm and 0 the x. So this dowel now is on the centre. Now all I need to do is move down ½ inch, centre drill, and drill a hole. need to drill the tapping sides for 5mm. The last job is just to tap the 2 holes and I can fit the handles. I'm just finishing off the die holder by making some screws. I've got 3 4mm cap heads. I've put a nut on the cap head and a washer and tighten the nut and washer up onto the end of the cap head. I'm holding the cap head in the chuck jaws and I'm using the washer to straighten it up on the face. Now I'm turning a 30-degree angle on the end just to give me the point for the location in the die. In this case I will leave the flat on the end, so that one's done. Well, that's the finished die stock, and that's it for today. Well, thanks for watching. I'm sorry about the voice, I'm just recovering from a cough. I hope you enjoyed it. We'll see you next time. Look after yourself.